if you guys have you guys ever seen Khan Academy before? Have you ever heard of? Okay, so good. A few of you have. So the guy's name is Khan, and he's kind of a very well-known YouTuber for teaching math. This is just a video that's basically proving, and there's actually a second part to this video, but we're not going to watch the whole thing. The point of you guys being here is you probably want to see me in person, is he actually goes through one of the properties that we learned last week about parallelograms. And that property was that if a quadrilateral is a parallelogram, then the opposite sides have to be congruent. Now, I would like for you to notice that his notation is a little bit off, and that's not a big thing. But technically, when we talk about things being congruent in terms of segments, we usually have segment symbols and then tildes above the equal sign. But that's not a big deal to me. His proof is very good. And by the way, you'll notice he didn't even really quite write a 2-column proof. He basically just, and that's all a proof is he goes through the argument of why the opposite sides have to be congruent. Not that they might be congruent, they have to be congruent. So if I know this bottom side is 7, that top segment also has to be 7 if it is a parallelogram. Hopefully you will notice that he used some theorems that we worked on last semester, like the alternate interior angles theorem. He also talked about SAS. Do you guys remember what ASA stands for? Angle, side, angle. That was a big part of our chapter 3 test when we were trying to prove triangles were congruent. Now, why am I bringing all of these things up? I want to make sure I do a good job, for those of you that are new to me, of understanding how I structure my modules in the Canvas class, okay? Because it was my observation last week that some of you did not do your homework. In fact, some of you didn't even log in to do your homework. So I want to make sure I go through some of these things with you. First of all, the very first module is how you access Math Excel for School, which is where you get your homework, and the online textbook. All of that information is right here. There's a video for helping you figure out how to set up your Math Excel. Your Math Excel for School.com. And there's also a PDF document here with all the codes that you need to get that set up. I have a video here for showing you how to access the online textbook. And then here's that information if you need that as well. So if you're struggling, you're like, Mr. Allen, I don't know how to get to the homework. This is how you do that, because Canvas is the first place that you should go. So let's look at this week. This week is January 11th. Now, technically today's January, I think it's the, 15th now, right? Is that 11th, 12th, 13th, 14th? Maybe is today the 14th? Oops, 14th, sorry, not 15th. Today is the 14th. Tomorrow is the 15th. So this week, I have already created a video on what we're going to learn today and tomorrow. In fact, I made this video. I probably made it sometime last December. That video has already been uploaded. Has anyone, by chance, just show of hands, has anyone watched that video? Okay, good. I see one person at least raising their hand, so that's good. Guess why? Do you think I made that video just for the fun of it? They're not really fun to make, to be honest with you. They're kind of a pain. I make that video so that you have an opportunity to see the math that we're going to be doing in class before class begins. And you guys are at a great advantage because you guys don't have me until Thursday and Friday. So you had, and by the way, I posted this video last Friday. So you had all weekend, then Monday, then Tuesday, then yesterday to watch that video. And I think it's around 18 minutes long, if I'm not mistaken, that's 18 minutes. But if you would watch that video, the stuff I'm going to be talking about today and tomorrow might be a little bit easier for you to digest. So this is called the flipped model. So I would encourage you to watch that video. Okay. Then right below that, those are the actual notes that I used in that video. So if you want to have a copy of the notes that I used in the video, there it is. Now, this is what I want to get to next. Let's say you're sitting in class right now, either here in person or virtually, and I go through this stuff and you're like, oh my gosh, he goes way too fast, or I don't understand what he's doing, or maybe you're actually not here and you're not even hearing what I'm saying right now. What you could do is, in addition to my video, which is okay, I found 3 other very good videos. They're probably even better than my video, which I'm not really embarrassed to say that because I'm not a professional YouTube guy. There's 3 other videos. So here's one on proving that a quadrilateral is a parallelogram, which is exactly what we're going to be doing today. And then these 2 videos are for what we're going to be doing tomorrow. Then right here, it says homework, mathexcelforschools.com, section 6.3 and 6.6. So then you click on that, and it says each week, student will find assessment available through sections, blah, blah, blah. And here's that Math Excel. That's where you're going to do your homework. You have to do your homework there. Okay? That's not optional. If you don't do that homework, those scores are zeros right now, and you need to get those done. And by the way, you don't even have to get all of the problems right. If you will get 85% or more of the problems right, and there's certain points associated with each problem, then you'll get full credit for your homework, like an A+. Okay? Now, by the way, those of you that are already doing that, you're probably going to say, Mr. Allen, why are you going through this? We already know. If you had me last semester, you know how this works. But over half my students now are new students. So that's why I'm taking time doing this. So here's the, let's see here. So here is the homework. By the way, here are some extra problems. Notice I wrote not required. So if after you've done all this, you're getting a little bit nervous about the quiz that's coming up next week, you're like, oh man, I want to make sure I do good on that first quiz. First of all, here's a quiz review, and I'm going to give you that tomorrow in class. Actually, those of you that are here today, and I'll show it to you right now. I made up a quiz review for you to look at. Now, later on this week, the answers to the quiz review are going to pop up as well. Do you think it's a good idea for you guys to actually do that quiz review for next week? I think it would be a great idea. Okay, that'd be a great idea. Now, I'm going to stop here. Does anybody have any questions about how Mr. Allen's module works in Canvas and how to access homework? This would be a great time for you to ask. Okay, so again, if you have questions, feel free to put them in the chat, send me an email, do whatever you need to do. But please don't wait till Saturday to ask me a question about homework because it's due Friday at 9 p.m. All right, so let's go ahead and do some notes and practice. So I'm going to go ahead and get out of this. I'm going to go ahead and keep. And this is going to shut off now, which always does. There we go. All right. Okay, so now we're going to get into today's lesson, which is on proving quadrilaterals or parallelograms. Now, guys, those of you that are here in person, I'm going to go ahead and give you a copy of the notes. Okay, so this lesson actually, I'm not going to say it's the easiest lesson, but I will say this. It's kind of like what we did last week. In fact, it's very much about like what we did last week. In fact, so let me show you what I mean by that. Last week, we did section 6.2, which was basically on properties of parallelograms. And so, for example, we figured out last week, if it's a parallelogram, in fact, I'll just talk about what Khan Academy video did. If it's a parallelogram, what did we find out was true about the opposite sides? They're congruent. This is what we did last week. This was on your homework last week, section 6.2. Now, let me just show you what we're going to do this week. And it's probably going to make sense. We're going to do, actually, I'm going to save myself a teachable moment here. We're going to try to show a quadrilateral is a parallelogram. In other words, if opposite sides, oops, if I can spell sides, of a quadrilateral are congruent, guess what I can conclude? I'll give you a hint. Up here I said if it's a parallelogram, we can conclude that opposite sides are congruent. Down here I'm saying if opposite sides of a quadrilateral are congruent, guess what I can conclude? It's a parallelogram. I'm going to use this symbol for parallelogram. It's a little like parallelogram shape. So it's kind of the same idea. Now I'm going to ask a really important question. In fact, I'm going to ask it of the virtual students right now because I feel like I'm not getting a lot of feedback from you guys. Virtual students, what is the word that we use when we take this and switch it around? If you would type that word in the chat. Guys, don't say it out loud. You know what the word is? Does anybody know what, Tomas, do you know the word? Let me write it up here like this. If this, you guys remember this? P arrow Q? What do we call this when we take them and switch them around? Nobody in the virtual land is helping me out here. Okay, so this is tough, guys. I'm gonna just, do you know it? As soon as I write it, you guys are gonna be like, "Oh yeah, I knew that." It does. It does. I'm giving it to you, man. The word is converse. Do you guys remember that word from last semester? If I have if this, then that, and I switch them around, that's called the converse. This is the converse of that. I'll call this statement 1, statement 2. Those are converses of each other. We're just taking them and switching them around. So what I'm trying to tell you is, if you understood what we did in section 6.2, then really you should be in pretty good shape for 6.3 because it's all the same stuff, except now we're just going to do the converses. In fact, let's go back and look at our notes for this week. There are 5 ways. There are 5 ways that you can confirm that a quadrilateral is a parallelogram. Number 1, I forgot. Guys, those of you in virtual land, I forgot. I'll send you the link for these notes here in just a second. There are 5 ways. Number 1, if both pairs of opposite sides are parallel, then it is a parallelogram. And that should make sense because that's just literally the definition of a parallelogram, right? Guess why we call it a parallelogram? Because opposite sides are parallel. So if opposite sides are parallel, we can conclude it's a parallelogram. Look at this next one. I'll call this 1. Look at number 2. If both pairs of opposite sides are congruent, that's what we just talked about. If both pairs of opposite sides are congruent, then it's a parallelogram. This is the converse of what we did last week. Last week would have said, hey, it's parallelogram. What can you conclude? Opposite sides are congruent. Number 3, if both pairs of opposite angles are congruent, like in this picture here, it has to be a parallelogram. Number 4, if the diagonals bisect each other, that was like one of the ones we did in the warm-up, it has to be a parallelogram. And then number 5, this is the hardest one to remember, so I'm going to put a star next to this. Number 5, if one pair of sides is both parallel and congruent, it is a parallelogram. So there are 5 ways to prove a quadrilateral is a parallelogram. So when you're doing your problems today, when you're doing your homework today and tomorrow, there's 5 ways to do it. And it should seem very familiar to what we did last week. So what I'm going to do now is I'm actually going to, I want to give those of you guys that are in virtual land a copy of these notes because these are a little bit different than what I put on Canvas. I'm going to let you guys here that have the actual notes in front of you. I'd like you guys right now to see if you can figure out number 1 while I get the notes there for the virtual students going.
I did not join the Google Meet, just because it was being recorded, but that'll be something I can use.
Yeah, it's okay.
Okay.
Yeah, no problem.
I just, you said it in the admin council. So I was looking for my calendars, semester one, nobody's really into that for me.
Correct.
All right, sorry.
Send me an email and I'll try to figure that out. Okay. Okay, guys, you virtual guys, if you want these notes and practice problems, they're in the chat. Okay, so let's go ahead and get started with this. So here's what I'm going to do with these as we start working on them. And I just remember this is locked, so let me unlock this. Which of these 5 reasons is going to give us what we need for this problem? Is it number 1, that the opposite sides are parallel? Number 2, that the opposite sides are congruent? Number 3, that the opposite angles are congruent? Number 4, the diagonals bisect each other? Or number 5, that one pair of sides is both parallel and congruent? Which of those 5 do you think we're going to need for number 1? Yeah, see, Anthony is saying number 3, and that's correct. So what you're going to do, what you're going to use on this problem is number 3. And number 3 says, in order for this, we already know that these 2 angles are congruent. We also need these 2 angles are congruent. And if those 2 angles are congruent, then 4x has to equal 3 times x plus 6. Because that's what congruent means. Congruent means that they have the same measure. So now we've got ourselves a little algebra problem. So we got to do a little bit of algebra. So we're going to review some of our algebra skills. Does anybody remember what property this is to get rid of those parentheses? The distributive property. Good. So we're going to get 3x plus 18. Now I'm going to minus 3x on both sides. And that's going to give me x is equal to 18. So now we have x is equal to 18. So that's going to be our answer for number 1. And the way we got our answer for number 1 is we use the fact that if both pairs of opposite angles are congruent, that's what makes it a parallelogram. So that's the idea we're trying to get here. What values of x or y must each figure be a parallelogram? So let's look at the next one here. So number 2. So they've got some things drawn. Does anybody know what those little lines in the middle are called? What do we call these lines here in the middle? They're called diagonals, right? So guess which one of these 5 we're going to use on this problem? Are we going to use number 1, that the opposite sides are parallel? Number 2, that the opposite sides are congruent? Number 3, that the opposite angles are congruent? Number 4, that the diagonals bisect each other? Or number 5, that both or one pair of sides is both parallel and congruent? Number 4, he says. That's exactly right. So we're going to use number 4 on this one. This one's going to be number 4 because we got diagonals bisecting each other. That's what we have to have. In other words, they have to be equal. Now, there's some bad news here. This problem, there's an x and there's a y. So this one's there's going to be 2 answers instead of just 1 because up here it says, what must x and or y be? So we got to do 2 things. So remember, if it bisects, then that means that this segment has to be congruent to this segment. So we'll start with that. So x has to equal 2y. Furthermore, this segment has to be equal. I'm not sure what I just did. Sorry, guys. Something just happened there. I think oh, there we go. All right, back. Okay. Then that segment has to be congruent to that segment. In other words, 2x plus 14 has to equal 5x minus 4. Which of those equations do you think we need to solve first? What do you think, Tomas? Do I need to solve equation 1 first or equation 2? Which one would you do first? Exactly. Why would you do number 2 first, Tomas? You're absolutely right. Can anyone help him out? Why do we want to do equation 2 first? Ishmael?
It's easier because we have all the information.
Yeah, there's only one variable. Did you notice up here in equation 1, how many variables are there?
2.
And since there's 2, there's actually infinitely number of ordered pairs that we could put in there. So this is the one we're going to solve first. So again, we're going to practice solving an equation. What would be your first step on solving this equation, guys?
Get rid of 2x.
Okay, get rid of 2x, fine. By the way, this isn't the only correct way to do this, but we'll go ahead and do that first. So if I subtract 2x on both sides, I'm going to get 14 equals, and then what's 5x minus 2x? Well, duh, that's 3x. Okay, now what?
Add 4 on both sides.
Add 4 to both sides, fine.
And then divide by 3.
So let's see, what's 14 plus 4? I think that's 18, isn't it? And so then this would be, what, just 3x, right? Because those guys cancel. Now what?
So you divide.
Divide by 3, right? Divide by 3, divide by 3. And so we're going to get x is equal to 6. X is equal to 6. Am I done?
No.
Nope.
You plug in that 6
Yep.
up there.
Correct. Can you do that in your head? So it says x is equal to 2y. Does anybody want to take a stab just using mental math? What do you think y is?
6.
Nope. 3. Y has to be 3. Let me do it in blue. Y, therefore, has to be 3. Now, think about it. If I put 6 in here for x, I have to divide it by 2, which makes it 3. So y has to be 3. So there's our, so you can see this problem was a little bit more involved. We used property number 4 to get it going. Okay. Let's just do one more. Let's do number 3, and then I want to give you guys a chance because we're getting close to about 15 minutes left before we go to support time, and I want to make sure that everyone's okay to get some of these problems, practice problems done. Okay. So let's look at number 3. Number 3 says this side's 4x, and it says these two sides are congruent. It says this side down here is x plus 16. Oh, you know what? I just remembered something else. Ishmael kind of helped me solve this last equation, right? Is that the only way that you can solve that equation is exactly how he did it? Tomas, you're shaking your head no. Yeah, you could have done it in different steps, right? You will get the same answer, though. So I just want to make sure you guys remember, just because Ishmael did it this way, you may have, minus 14 first or something like that. You'll still get the same answer, okay? All right, so let's look at number 3. This will be the last one we're going to do. We're going to skip number 4 for now. Let's look at number 3. Let's see here. The ways we can prove that a quadrilateral is a parallelogram is if both pairs of opposite sides are parallel, if both pairs of opposite sides are congruent, that's number 2. If both pairs of opposite angles are congruent, that's number 3. If the diagonals bisect each other, that's number 4. And then number 5, if one pair of sides is both parallel and congruent. Which one, and I'm going to have to try to remember which one it is right now. I think I remember. Does anybody know which one this one is? Okay, I see a lot of you guys holding your fingers up with the 2 there, so that's good. So we're going to use property number 2 here, okay? And so property number 2 tells us that opposite sides have to be congruent. Well, we already know that those two guys are congruent. We also now know that those two sides are congruent. In other words, 4x has to equal x plus 16.5. Now, I'm not actually going to do this one. I want you right now figure out what the solution is to this equation. I want you to do it on your own right now. 4x equals x plus 16.5. Okay, guys, virtual students, you guys have been leaving me hanging now. This is your opportunity. Help me get this one right. Someone type in the chat, what is x equal to in this problem? Just type in the answer. Say that again, Jacob.
5.5.
Thank you, Jacob. You are the man. I appreciate it. That is correct. X is 5.5. That is exactly right. Okay, good job. All right, so guys, we have about a little bit over 10 minutes now before we go to our support time, and I'm going to talk about what we're going to do with our support time today in a little bit. But what I want you to do now is those of you guys that are in virtual land, I sent you these notes. What I'd like you to do is I'd like you to flip it over to the back, or in your case, you guys in virtual land, you'll just scroll to the second page. I'm going to give you 10 minutes, and I want you to get as many of these done. I'm just to let you know right now, there's a proof right here on number 9. That's a pretty tough problem. So you might want to save that one for last. You might want to do these here at the top first, and then these down here at the bottom last. I'm going to give you 10 minutes, though, to start working on those. And I'm not going to put you in breakout rooms today. I'm just going to let you can kind of work by yourself if you like. I'm going to give you 10 minutes to start working on those problems. Same thing for you guys here. You got 10 minutes to work on those problems. Actually, you know what? Yeah, we'll leave that there. Okay.